welcome back to my channel. So first of all, I would like to thank you all guys. In our channel, we have achieved 500 plus subscriber now, and my watch time is also increasing. After a long time, I am continuously uploading the videos, so that's why it's happening, and it's all love and support. So as far we have now been completed the six videos in our AI engineering playlist. Okay, so we have these six videos. If you are coming to this video for first time, you can watch these videos from the first, from setting the tool to vector indexing and all. So uh, in this video, we will improve our RAG application. Simply not just RAG application. We will be thoroughly learn the LangChain more, and we'll experiment a lot of tool with it, like how we can use a lot of tool. Like you must have heard Tavily, and Tavily why it is used for, and we will we'll go through a lot of thing, like how we can use route query. Like it is a although it's advanced topic for you to begin with, but not as much as advanced. You can digest this concept. This is so much easy for you. This is our Tavily, and we will integrate it in our RAG application. Okay, so let's get jump into our video and improve our code. Okay, so I opened my Windsurf, which is my VS Code text editor. You can use whatever you want. I'm using Windsurf, which is a very awesome tool. Let me increase the font size a little bit. Okay, and now we can start with our video. Okay, so up till now we have created this simple RAG application where we can ask simple questions related to our document, which is this, which we create embeddings of. Okay, so we have a very limited kind of data where we fetch our data from, where we can ask our query from. Okay, so what if user asks something that this blog doesn't have? Like if a user come to your application and write like what is today stock price of Reliance. Okay, so what it will return, let's just see. Oh, sorry, we had to, since I started this application, Windsurf, so I had to rerun um, all the cells one more time. So I will rerun all the cell, and you can see these cells are executing, and retrieval happened, chunking of data is happening, vector storage is happening. So here one more thing I want to tell you guys, like how we can store our embedded data. Like every time if you run this every day, if you run one more time, it will just start from the beginning. Okay, so we can overcome this problem by storing our embedded model to this file, and we can do this just quickly. I want to tell you, like it Chroma, we have option something. So you can see we have something like persist directory, and we can pass our directory to it. Like I can pass something to our file name. So I want to store our data into a directory called anything you want to give. I want to give it to Chroma VDB vector database. Okay, so it will store in this folder. So if I run this, you will see something, a folder will be created naming Chroma VDB. Okay, so it doesn't work now until it. Okay, so if you run this again, it will again create this file. Okay, so what we have to do, we have to do something like tweak our application a little bit. We have here our OS, so import our OS, and we will like check if we have this file. We will not assign vector storage and rerun this from document and re-embed all those data which is fetched from the web. Okay, let me delete this. This is empty shell. So I will just say, like if os dot path dot exist, and since this is a current folder, I will look for the path Chroma VDB. Okay, VDB, and if this is exist, if it is not exist, so I will do something. I will create the vector storage from scratch, like from retrieve document. If the file is exist, then what should I do? I will do vector storage, chroma dot, and we have something. I'm not remember it right now. Something like we can search on the Google. Load stored chroma db. Load load from file. Load data from vector database, and we have something. It will, yeah. So we have this thing vector and chroma, and I will pass our chroma persist directory, and we will give the path chroma vdv, and we also have to pass our embedding model here. So we have our embedding model here. Okay, and now if I rerun this, it will give an error because it got unexpected keyword argument, which is embedding. Embedding function it is. Embedding function. So if I run this, now it's fine. It's running very fine. So if I rerun this cell, it will quickly load. See, it's take 0.0 seconds. Previously it was taking 5 6 seconds. Okay. So now we can see we do not have to recreate our embeddings every time. So we have resolved this issue. Now we will run this cell and this cell and this, and let me rerun this one more time so that we come to our where we were previously. So we have this application. But what if user asks something like what is the today's stock price of Reliance? The LLM will answer like the provided context does not contain any information about the stock price of Reliance. The context appear to be related to a blog post about building LLM centered agents does not matter. It means it is unable to answer this question. But we can tweak our application and integrate something that will provide the capability of doing web search. So LangChain also provide. You must have heard of like Tavily. We saw this. We saw it in the starting of this video. So we will just go ahead and go into this quick start, and where we will see we have a basic implementation, Python implementation here. We just need to initialize this and we can go ahead and with our uh, with our web search. Okay, so what we need, we need a API key. So you can register here, get an API key. Grab your API key. Okay, so I will continue with Google. So I have successfully logged in with my Google account. You can do from your as well. So I have this API key. I will copy it. You can just create API key from here. You can key name whatever you want for development for all. Just follow the standard method and your API key will be created. Okay. So it will be created. Then you will just have to copy and go into the .env and you have to paste it. Tavily API key. And so how I got this key name? It is convention. If you go into LangChain Tavily, they have like predefined the API key. Like what will be the defined key? You can see they say Tavily API key. Okay, so I inserted out API key, and then if I close this, and if for example, like let me create a markdown, add web search to my rack. Okay, so let's just forget everything and add this feature. So For this feature, we have to import LangChain. I can convert this in chain cell to code. It will LangChain, and we have LangChain Tavily. So if you haven't installed this LangChain Tavily, you can install it. Why? Remember, I told you the command. You can uh, go into your project like AI engineering is mine, and I will simply add and type like LangChain Tavily. So in my system, it is already installed, so I don't have to do it again. And I will simple import Tavily search. Okay. And I will initialize the search like web search Tavily. So we have now our tool initialized, and we can do something like this, like response and web search dot invoke, and we can ask our question. But see, it will not run. It will give an error. But I want to analyze what can be a problem. I know it will not run. It will give an error. Why it is giving an error? Because it is not getting the API key. Did not find Tavily API key. Although we have set up this, but we haven't rerun our first code. Means it has still a old env's setup. So if we rerun this, it will load all thing. And now if we run this, it should run. Okay, so we are getting our response. So you can see like in which we are getting a lot of results from a lot of sources from this website. We can fetch the first result and we see our result like we are getting in industry price today 1372. So we are getting the result. Previously from this approach we were not getting anything. It was possible to enter the question using the given context. So how we can integrate this into the LangChain? Okay, so for this purpose we have to tweak our application a little bit and then add this functionality. So I will remove this stuff. I will remove this stuff and we will recreate all of things. Okay, I will create this cell and will integrate into our existing LLM chain. Okay, so what we have to do, I will define a function like query route or route query. Okay, like we don't want to go and web search every question user asks. If user asks the question that is exist in our embedded data, then I want our LangChain, our AI to answer from that source, not from the doing web search. Okay, it will save our API rate. It will save our API call, and eventually it will save us a cost. Okay, because the Tavily is not free, and it they have a free token for like 1,000 credits you got for development purpose. You can go and check their pricing in billing section. You can pay as you go kind of do. Then you can do in unlimited, not uh, your your demanded credits. Okay, so I will create a route query so that I don't uh, drive out every query to the Tavily. So I will create something like this query results. Okay, so how we will do that? Like let me tell you something. What are the flow, what are the basic flow? If user query it, go to the retriever and retrieve the data from our vector storage, and then send it to our LLM. So this is the flow, send it to our LLM. So how we will do that? Just see. First, if I get the query, I will like try to get the data from our vector store which is similar to our query. But what what I am expecting, I will expect a number like something. If query matched, then it will give something like 80% query match, then only I want to give result. If our matching below 50%, then I will like assume that we do not have successful match in our vector database. Then I want our chain to go to web search and retrieve the result and give to the LLM. Okay, this is what we want to tweak. The middle thing. Okay, the middle thing, like we saw we have something like this. We query the question and go to the prompt, then it go to LLM. So retriever is all we want to tweak. Like retriever, we don't want to retrieve data from fetched vector storage. We want to fetch our data from web search. So that we will tweak it. So how we will do that? In retriever, we have something like function, vector storage. So I will initialize it like match query, match result rather. And if we type vector store, we have something similarity search with relevance score, I think something kind of relevance score this is. And what this will query and what it output, let's this return. I want to show you what is the output, and let's call this, and rather storing it to variable, I will directly print it, right? Query, what is task decomposition. When I run this, I will get a result. Okay, see, we are getting tuple now. In tuple, the first thing what we get the data, and second we will get a matching, like something this. So this matching is something what we will tweak our function. Okay, so if we have something like this is like cosine similarity. Hope you are getting my point. So this is the cosine similarity. Okay, means this is the kind of number we will I mean this is number we will simply put if else condition. If something is above 0.5, then we will return the result from fetch vector storage. If something is from 0.5, then we will do the web search. So let's something ask to test it. Like if I ask the question this, let's see what the score is. Okay, and if I do this, and then also it will return something, but now it is the score is less, 0.5656. Okay, and we have one more function here, like score. We can do something, we also which is also used to calculate the score. Similarity search with score. Okay, and then we will do, and what it will do, it will return the opposite, like how much higher this number returned. Okay, the how much higher it will be, the lower it is matched. Okay, and how much lower this score will be, the higher will be the match. This is like opposite of relevance score, like how much the relevant the data is, and how much irrelevant the data is. It's kind of reverse of it. Hope you are getting my point. So the search the search with score returns something, the project, the higher number it is, the number range will be like 0 to 1. Okay, so it returns 0.6. It is higher, it means the low match. And if the result is lower, like if I ask like task decomposition, you will see the number will reduce. Scroll it to the end, you will see the result is like 0.6693596. Okay, and if I remove it also, then it should match more. So we are you are getting almost 0.4. So hope you are getting my point. This will decide our the route. Okay, so I will define our function in it. So how we can select this thing? So our score will be match result, and we, since it is a list, I will select this first, and it is tuple, then I will select first. Okay, this is score. So if score is less than 0.5, okay, means our similar search is found, then I will return the score, return like match result, the first 0, and then zero dot page content. Page content is what, like, content what we are expecting. Hope you are understanding this. You can rewatch one more time to understand the to get the clarity. And else, if the score is above this, means we are not getting relevant search. So we will do like not not found in vector storage. Um, Searching on web, and here we will do our web search. Here we will do the web search and return the result. And how we'll do that? We will initialize our LangChain. Let me, how much time it is? It is already 23 minutes. Okay. So we will initialize our application like from LangChain, Tavily, import. I shouldn't have cleared those things, but don't worry. Tavily, search, initialize it, and I will do something like response, um, web result, and we'll do web search dot invoke, and our query will be here. But remember, the web result shows something very, like, lot of it show lot of result. So we don't want to return our LLM those object, or LLM expect the string. So we'll return the string. Like, I want to return web result dot results. It was, I think, and I will pick the first whatever the list it is, and what I will return it, return the content of it. Let me confirm it if we are going the, yeah. So it is giving the results list, and we are getting our content from this. Okay, so we are returning the return. So I will return this. Okay, so now we will if I check it this function by calling the function, then I should task decomposition. We are not, remember, this line is not printing, means it is returning the data from our vector storage. If I do something like Reliance company today stock price, not found in vector storage, searching on web, so we are getting our result 1372. Just don't worry about this thing. Okay, we will improve our template to return only the response. Okay, so you, I think you got the point, like how we are routing our query to go on to different tool like vector storage or the web search. So we are doing great. So now we have our route query, but how we'll call it now? Every time we don't want like call it like print. How we'll pass this information to our LLM? So we will do a chain. We will do chain here. So our tool chain will be like something, and we have now route query. So how we will pass our query to this? So this is our question. And since also we are our prompt expect the post context and question. So remember, we were talking about tweaking our retriever. So our retriever is nothing but this route query. We are getting result from here. See, return is our retriever which is giving the result. Okay, so we will use this. And how we will use this? I will just simple enclose into the bracket and do this, and I will pass the context here. And let's, for now, let's do the whole thing. Our question is we have runnable pass through. Okay, I think it is important. Runnable pass through. And what we do after this, we pass this to our two-way prompt, and our prompt will then pass to the LLM. But we don't want to uh, get everything from retriever. We want to use this route query. Okay, how we'll do that? So we have something like in LangChain port dot runables import runnable lambda. Okay, so what it will do, it will execute two things parallelly. If I do this runnable lambda and pass this thing route query, so it should on asking question, it will like pass our question to this and query to this, and then we can get our result. So let's give it a try. So how we'll do is I will go ahead and run this, and I will create another cell, tool chain dot invoke task decomposition response. We'll print the response. Let's print. Let's do this. And if I do this, see, we are getting our result. Task decomposition can be achieved through several methods, including large language model, simple prompting, and this is what we are getting. Okay, and we are not sure like if we are getting from our vector store or from a route query. Okay, but how will ensure it? How we will ensure it? Let's ask that question one more time and see if it is printing or not. Not found in vector storage, searching on web. You see, so we are successful. We are successful in implementing this feature like routing query. This is the proof. This is printing means this block hasn't executed. This block was executed. So this is the result, guys. Now our RAG application is more robust, which can answer anything, whatever you ask. Like if I ask, who is Mr. Narendra Modi? Not found in vector storage, searching on the web, and we will get our response. Narendra Modi is Indian political who has been serving as a Prime Minister of India since 2024. So hopefully you got the point. Like we learned so much into this video. Like we learned like how you can store the fetched like vector storage permanently to our disk, and how you can implement Tavily search and use it as a tool to our LangChain to get the query that is not that cannot be fetch the result from your stored vector database. Okay. So now we are done with this video. We saw Tavily. If you have any doubt, you can definitely ask to this comment section down below, and I will be happy to help you. Okay, and in future video we will implement a lot of tool, like you just saw Tavily search here, but we can do more mathematical thing. Like if we ask mathematical question, then we will use different tool. Like for web search we are using this, and for mathematical question we can use different kind of uh chain. We are using tool chain here, but we can define multiple chain here. Okay, so hope you like this video. If you do, so don't forget to hit the like button and subscribe my channel. So see you guys in the next video. Bye bye.